everybody. So I've had a request to do a couple problems. So from page 27, 35, 37, 39, and 41, and from 118, numbers 45 and 46. And 45 and 46 are really similar, so I'm just going to do 45 in the mix. All right, so the problem begins on 35. You have y to the 7th raised to the 3rd divided by x to the 14th. Well, you can multiply these two exponents because you're raising an exponent to an exponent, so it becomes y to the 21st divided by x to the 14th. Remember that division is multiplication by the reciprocal, so it's multiplication by 1 over x to the 14th, and we just put them together, basically multiplying straight across, and you put that over 1 and multiply straight across. So you have y to the 21st over x to the 14th. All right, 37, your problem begins 5 squared m divided by 5 to the 0 power times m. And remember that anything to the 0 power is equal to 1. So this is really 25m divided by m. And you could at this point in time recognize that the m's will cancel. But if you want to convert the division to multiplication and have it 25m times 1 over m, the m's will cancel and you're left with 25. For 39, you've got 2 cubed over 3a to the negative 2 power, and this is all to the negative 2 power. And that negative says let's move that entire expression up. So it now reads 2 cubed times 3a, the quantity squared. So this is really 2 cubed times 3 squared times a squared. Well, 2 cubed is 8, 3 squared is, whoops, screwed up, is 9. And so we have 8 times 9a squared, which is 72a squared. All right. Yeah, what I did was here, I had a moment, and I went, oh, it's 3 cubed. Anyhow, and I wasn't, that's not even right, so ignore that. Just had a moment. Okay, so 3 squared is the 9, 2 cubed is the 8, and then you get your 8 times 9 is your 72. 41, you have b to the negative 2c, all raised to the 3rd power. I decided to deal with this one a little differently. Since there are 3 of them, I just wrote out all 3 of them. So I have b to the negative 2c, b to the negative 2c, b to the negative 2c. Because they're like bases, I just add the exponents, and I have b to the negative 8. And then c to the 1st, c to the 1st, c to the 1st is c to the 3rd power. And that's a negative exponent, so it moves down into the bottom. Okay. On page 118, we have to verify that this value here is a solution to this problem. Well, what does it mean to be a solution? A solution means it makes it true. Okay, it makes the statement true. So you could do x to the 6th plus 1 and add it to 0, or you just need to show that x to the 6th is equal to negative 1. So I'm going to take the square root of 3 over 2 plus 1 over 2i raised to the 6th power, and I'm going to generate a negative 1. Okay, so what I did was I wrote it out twice, and then I said, the 3rd bit is to the 4th power, because you got a 1 here, you got a 1 here, 1 plus 4 is 6. I FOILed this out. I got 3/4 plus the square root of 3 over 4i plus the square root of 3 over 4i plus 1/4 I squared. Remember that I squared is negative 1. So I have negative 1/4 and 3/4, and that's going to give me 2/4, which is 1/2. And then the square root of 3 over 4, square root of 3 over 4, those add to 2 square roots of 3 over 4i, and those will reduce down as well to 1/2. So really, for every pair that I have, I get this expression. So I looked at it this way. So I could say, oh, well, this actually breaks up into another pair and another pair. And so I have, traveling back here, 1/2 plus 1/2 square roots of 3i. And then I have times 1/2 plus 1/2 square roots of 3i, 1/2 plus 1/2 square roots of 3i. And I didn't put my 1's there, didn't need to, but because I'm saying it that way, I will. And then I multiplied these two. I took this, and I just said, all right, I'm going to leave you and let you travel along with us. So 1/2 times 1/2 is 1/4. 1/2 times the square root of 3 over 2 is square root of 3 over 4. This one times this one, square root of 3 over 4. And this one times this one is 3 over 4i squared. And remember that I squared is negative 1. So this and this combine, giving us a negative 2 over 4. And these two combine to 2 over 4 square roots of 3i. So those will reduce. I have negative 1/2. I have square root of 3 over 2. And I grab the other part and pull that back. So now I have negative 1/2 times 2, which is negative 1/4. I did negative 1/2 times the square root of 3i over 2, and I got negative the square root of 3i over 4. Did these two together, I got positive the square root of 3i over 4. Those eliminate, and so then I have the square root of 3 times the square root of 3. Well, that's the square root of 3 squared, which is just 3. I squared is negative, and I get my 4. So I have negative 3/4 added to negative 1/4, and I get negative 1. It is a solution. Okay, I have some requests for some more. I'll do those as well in a bit.